In the diagram below, Vy is equal to Vz and angle W1 is equal to angle X1. Prove that A, Vw is equal to Vx, B, Wu is equal to Ux, and C, triangle YUW is congruent to triangle ZUX. Let's start with part A. Prove that Vw is equal to Vx. Let's start by making Vw red and Vx blue. We can use congruent triangles to prove that two lines are equal. So we're going to use this idea to prove that Vw is equal to Vx. Vw lies on triangle VWX, but so does Vx. We need two separate triangles in order to prove that they are congruent. VW also lies in triangle VWZ, so let's make this triangle red. Vx lies on triangle VXY, so let's make this triangle blue. If two triangles are congruent, all corresponding sides are equal and all corresponding interior angles are equal. So let's attempt to prove that these two triangles are congruent. So we can say in triangle VWZ and triangle VXY. Now we can look at the information we've been given in the diagram. Straight away, we can see that Vy over here is the same length as Vz. So we can make the statement that Vy is equal to Vz. We know that this is true because this has been given to us in the diagram. The question also tells us that angle W1 is equal to angle X1. W1 lies over here in triangle VWZ, and angle X1 over here lies in triangle VXY. So let's make the statement that angle X1 is equal to angle W1 because this has been given to us in the question. Now we have one pair of equal sides and one pair of equal angles. So we need to find one more side or one more angle. We don't have enough information to find another pair of equal sides. So let's look at angles. Angle V up here lies in both triangles VWX and VXY. It is common to both. So now we can make the statement that angle V is equal to angle V. And we use common as our reason. Now we have two pairs of equal angles and one pair of equal sides. So let's double check that these are corresponding angles and sides. V is the first letter in VWZ and in VXY. So V is a corresponding angle in both triangles. W is the second letter in VWZ and X is the second letter in VXY. So W and X are corresponding angles. Finally, V and Z are the first and third letters in triangle VWZ. V and Y are the first and third letters in triangle VXY. So these are corresponding sides. So now we have two pairs of corresponding angles and one pair of corresponding sides. So we have proven that triangle VWZ is congruent to triangle VXY because of two angles and a side. So we use AAS as our reason. If two triangles are congruent, then all three pairs of corresponding sides are equal, which means that VW must be equal to Vx. Now we can move on to part B. Prove that WU is equal to UX. WU is a side of the smaller triangle down here. Let's make it red. UX is also a side of this triangle, so let's make it blue. Now, both sides we are working with lie in the same triangle, so we cannot use congruency. Here, we need to prove that WU is equal to UX. So we need to prove that two sides of this triangle are equal, which means we need to prove that triangle WUX is an isosceles triangle. Remember that an isosceles triangle has two equal sides, but it also has two equal angles. So in this case, if WUX is an isosceles triangle, then angle W2, let's mark it in green, will be equal to angle X2. So let's mark this in green as well. But we don't have any parallel lines or any information about triangle WUX that we can use to prove that angle W2 is equal to angle X2. So let's leave our green angles and make the rest of the diagram black. Throughout this section, we've been working with congruency. So let's see if angle W2 and angle X2 lie in any other triangles. Angle W2 also lies in triangle WXZ. So let's make this triangle red. Angle X2 also lies in triangle XWY. So let's make this triangle blue. Now we have two triangles that we need to prove congruent. When you have a question broken down into parts, such as part A, part B, and so on, you can use your answer from one part to help you with your answer to the next part. In part A, we've just proven that VW is equal to VX. As our reason, we simply say proven above. This shows us that triangle VWX, let's make it purple, is an isosceles triangle, and we can make a note of this over here as well. An isosceles triangle has two equal sides and two equal angles, which means the whole of angle W, let's make it green, is equal to the whole of angle X. Let's make it green as well, because these angles lie opposite equal sides. Now let's tidy up our page, take out our purple sides, so we can focus on our two triangles. We don't have any parallel lines or any given internal angles, so let's look at the sides of our two triangles. In part A, we found that VW is equal to VX. In the diagram, we can see that VW is made up of VY and YW. So we can make the note that VY plus YW is equal to VW. We can also see that VX is made up of VZ and ZX. So we can say that VZ plus ZX is equal to VX. From algebra, we know that if two values are equal, then their equations are equal as well. We know that VW is equal to Vx, which means that Vy plus Yw is equal to Vz plus Zx. So we can rewrite our equation as Vy plus Yw is equal to Vz plus Zx. But the question also tells us that Vy is equal to Vz, and we can see this in our diagram over here and over here. So let's make a note that Vy is equal to Vz, because this information has been given to us in the question. If Vy is equal to Vz, then these values will cancel out in the equation, and we are now left with Yw is equal to zx. These sides are equal, so let's put two purple lines on YW and two purple lines on ZX. Let's make some space. And now we can attempt to prove our two triangles are congruent. So we can say in triangles WXZ and triangle XWY, we have already found that angle W is equal to angle X. We have already proven this. So as our reason, we say proven above. W is the first letter in WXZ and X is the first letter in XWY. So these are corresponding angles. We have also just found that YW is equal to ZX. We have already proven this to be true, so we use proven above as our reason. W and Y are the second and third letters in triangle XWY. X and Z are the second and third letters in triangle WXZ. So these are corresponding sides. Now we need one more side or one more angle. Both triangles contain the letters W and X. And in our diagram, we can see that this side over here lies in both triangles. So we can make the statement that WX is equal to side WX because this is common in both triangles. Now we have two pairs of corresponding sides that are equal and one pair of included angles. So we have now proven that triangle WXZ is congruent to triangle XWY because of two angles and an included side. So we use SAS as our reason. Let's tidy our diagram up a bit. We know that if two triangles are congruent, then all corresponding sides and all corresponding angles are equal. This means that we have now proven that triangle W2, let's mark it in green, is equal to angle X2. We can mark this in green as well. Let's make our diagram black again. Angles W2 and X2 both lie in triangle WUX. So let's make this triangle blue. Triangle WUX has two equal interior angles, which means that WUX is an isosceles triangle. Isosceles triangles also have two equal sides, which means that we have now proven that WU is equal to UX because these are sides opposite equal angles. And finally, we can move on to part C. Prove that triangle YUW is congruent to triangle ZUX. Let's start by marking our triangles on our diagram. Let's mark triangle YUW in red and triangle ZUX in blue. Now we can use the information we found in part B to prove that these two triangles are congruent. We have just found that WU is equal to UX. We've already proven that these sides are equal, so as our reason, we simply say proven above. U and W are the second and third letters in triangle YUW. U and X are the second and third letters in triangle ZUX, so these are corresponding sides. Let's quickly mark UW on our diagram with two green lines, and we can mark UX as well. We also know that angle X1 is equal to angle W1 because this has been given to us in the question. W is the last letter in YUW and X is the last letter in ZUX. So these are corresponding angles. Now we need to find one more pair of angles or one more pair of sides to prove that these two triangles are congruent. The diagram breaks up angle U into U1 and U2. These angles lie vertically opposite each other, so we can see that they are equal. So now we can say that angle U1 is equal to angle U2 because these are vertically opposite angles. U is the second letter in YUW and the second letter in ZUX. So these are corresponding angles. Now we have two pairs of corresponding angles. We now have two pairs of corresponding angles and one pair of corresponding sides that are equal. So we have now proven that triangle YUW is congruent to triangle ZUX. And as our reason, we can say AAS for angle, angle, side.